this
Thank you.
PowerPoint to show a few slides here. So the goal of today for a 1 hour webinar, familiarize you with the testing of three-phase motors, both low and high voltage, and that will be done live on cameras with the actual equipment. We'll use mega ohm meter and milliohm meter. I nicknamed them Millie and Meg, your two new lady or your family members, ladies, whatever in your shop. They're invaluable. So Millie and Meg will try to master those today. Also follow manufacturer's public safety instructions, published safety instructions, for high voltage. Wear the gloves, power downs, live dead, live testing, all that. Um, this is not a time to learn new tools and then get hurt with high voltage. So that's just a reminder on any high voltage vehicle, whether it be a hybrid, plug-in hybrid, or an EV. And just a little review from last month, part one, we did talk about brushless motors, how they were different. On the left, that's a brushed motor. On the right, that's a brushless motor. And all these three-phase motors are brushless, and you can see the three windings. Now, it may look like there's a lot more windings on some of the examples, like this great big uh, traction motor stator that I'll have, but they all end up being the same way. They're either Y wound or they are delta wound. This is something we're going to do today. Now, unlike higher current three-phase motors, these fuel pumps are ideal if you're not sure, is it the drive module, the ECU that makes the three-phase and sends it to that motor, that fuel pump, or is it the fuel pump itself, the wiring, those kind of things? I've got from Joe's Auto Electric. I'm not sure how to pronounce his last name, but I think it's CICI, it's a CC, or Khaki. I'm not sure how to pronounce it, but he's friends on Facebook, and he's got a nice shop, and he makes tools. It's out in the Philadelphia area. Joe's Auto Electric. We're using one of his. It's like a 15 amp three-phase motor driver, and I hooked it up, and it works, and we'll demonstrate it today. Now, what I won't do, I will set a bad example for you guys. You never run a fuel pump dry. Now, I know the brushes, because they don't have brushes here, aren't going to be a factor for heat and wear. You need lubricity. That's why fuel pumps need to have, either safety solvent run it through it if you're a trainer, or if you're a tech doing real world work, gasoline or diesel fuel in case of the three-phase lift pumps that are coming around a lot more. These are becoming more and more popular. We talked about them last month. I will run it dry because we make them. And I'm not going to be putting that on an Audi. That pump right there in that picture belongs on, I think, a VW or Audi application. And since it's never going to go in a vehicle, I'm just going to run it for a few seconds. You guys can hear it in the microphones, and you can see how the three-phase motor driver works. And that would be a way substituting for the vehicle's ECU that would be mounted several feet from the fuel pump itself. So we'll demonstrate that, plus the milliohm meter, and we could do the mega ohm meter on this pump as well. But we'll keep the voltage really low because it is not a, 500 volt motor. So we already went through what these wires did. That little bitty black one is actually a shield, and the three phases that are pulsed 120 degrees. We picked two, like the yellow and the red, and give it some power. It's not necessarily 12 volts as we saw last month. And then we change it, maybe the yellow and the brown, U and V, W and V. We do that every 120 degrees, and that makes the pump move without brushes, and it's more efficient working them that way, and that's why everybody's going to that style of pump. So there's a little bit close up of the shield for noise, and then the three phases. So we'll be checking the terminal retention and plugging in the Joe's Auto Electric three-phase motor driver. I've tried to make my own before, getting stuff off Amazon, and they work if you have a signal generator, but it's a really crappy waveform, and I don't like it. The Joe's is just like plug and play. Get some banana test leads, plug into the box, plug power and ground into the box, and three-phase comes out of it. It's pretty cool. You can change the speed. All right, so there's a UV and W, and we talked about delta and Y wound on the left. Y looks like a capital letter Y, but it's WYE. Some inventor from like Ohms and Kirchhoff, those kind of people. And then the delta wound looks like a triangle, like the Greek letter delta. And so how they connect for a common point is simply a matter of how the engineer decided, to package it into the electric motor assembly. But they all will have a U, V, and W that you can change your milliometer in different positions, and we'll do that with both the Pico and the little VC that will have. The Pico will be PC based, and the VC will have that on camera. That's just an inexpensive milliometer. And there's a picture of a more expensive milliometer, and I've got actually a bench model. Trying to look at the brand name on it. I think I want to say GW Instech or something like that. It is not really that much better, the expensive ones, than the inexpensive one underneath it, the VICI. So you can get those on Amazon for, I don't know, 150, 170 bucks, something like that, or less, and or the tool truck. So whatever you end up buying, don't worry if it's not going to be super expensive like the Toyota factory recommended tool, which I think the Hikoi is. Um, According to Isaac Rodell, who does all kinds of mobile tech work on both diesel and electrified vehicles, a friend of mine over the years, he said he can't really tell a difference in accuracy between the really expensive stuff and the cheaper stuff. I do like the Pico. Next time I see him, I'm going to ask him if he ended up buying one of those because it gives you a bar graph and it can be used for some other stuff as well. You want to know more about the Pico in action, just Google P10, which is a tool review magazine. It's online. And my buddy Scott Brown with Dick and Connie's Garage out in Southern California, a proud Tesla Cybertruck owner, does training besides run a shop, and takes his Cybertruck and pulls the frunk out and shows everybody what's going on. That guy did I don't know, 15, 20-minute demonstration and showed it the Pico version of the milliometer catching some intermittent high resistance issues with CAN bus. So a lot of tools can be used for multiple functions, not just necessarily what they were intended to be used for. We all know that if we turn wrenches, hey, that'll make a great pry bar. Don't use that. Oh, it's right here handy. So same thing with some of the electrical test equipment. Just be careful, don't burn anything up. All right, so we learned that using a meter was a futile venture. I'm referenced between ground and each of the three phases. This is a three-phase pump running, and I'm seeing 2 volts of DC and 6 kilohertz almost if you turn the freak counter on the Fluke 87 or 8. And then percentage duty cycle was 21, almost 22%. And then I went and looked at the AC side of things, flipped the meter to AC, and it was 4 volts of AC. What was it on DC? 2 volts of DC. So the test light and even the conventional meter on these three-phase motors, that's what we learned last month, is really not very effective. And that was the scope pattern. That's when I said, let's get the scope out. So there's a Pico 4-channel. The 3 smaller patterns at the top are, we're going between chassis ground, with the scope, and then referencing that, and then we're hooking to each of the 3 phases with 3 channels. And this is the 4-channel, which is the current probe, like a 0 to 60 amp clamp. And that's lining up perfectly with this phase right here. This is voltage, this is current. You can see the AC side of it. If this is 0 amps, we're going positive and negative. If this is 0 volts right here at this dotted line, we're going a little bit negative and a lot more positive. So it is definitely not your father's Oldsmobile's electric motor. This is new stuff. So let's get busy doing hands-on testing. There's the 3 phases, and that stator on the right is what I've got. And those things, I got to tell you guys, if you pull transmissions and engines, and I know a lot of you do, it's heavy work. It's time consuming. You got to have the right lifts and jacks and things to don't hurt yourself or hurt the components on the vehicle or drop the vehicle off the lift. When you get a motor generator out of a vehicle and you're going to do this kind of testing, I mean, you could do it right here if you can access it. In a lot of cases on electrified vehicles, it's getting harder and harder to access these cables to do the milliohm test. But when you get a hold of one of these puppies, It doesn't look like it's going to be that heavy. Oh my gosh. I felt like I had an 80-pound bag of concrete on my shoulder, moving it from the shop into my lab, my office here where I'm broadcasting from today. So beware, this stuff is dense and it is heavy. And obviously, you can see an overheated winding here. I don't have any smoking gun on a stator for a motor generator, but I do for an electric power steering uh, motor, which is a medium voltage. It's 42 volts. It's a prototype from back in my Delco electronics days. I did engineering classes, teach engineers. And I said, hey, do me a favor, bring in some stuff. If you're going to trash it because it's a prototype, and it's, you made a new one that's better design. And I got this electric power steering motor. It's three phase, it's 42 volts, and we will see not a burnt spot, but we'll see something else. I'll let you guys see it on camera, and it will fail the test with the milliometer. Love it. Love it when you can demonstrate an actual bad part. The mega ohmmeter is what we're using to look for shorts or even partial shorts. They call it high voltage leakage. So like these cables right here that are going down to MG2 on this, I don't know, 2013 Prius, whatever it is, um, you can go between each of these and chassis ground. So the chassis ground right here with the mega ohmmeter or insulation tester, as the Fluke 1587 sometimes calls it. There's an 1587 that's an FC. And I always wondered what the FC stand for. It's Fluke Connect. So you've got a Bluetooth app. I love this. I've got an Autel battery drain tester, plugs into the DC, the DLC, and measures the actual current going through the vehicle. That's kind of nice. And also can keep the vehicle alive through the DLC, pin 5 and 16, with a little gel cell built into the tool. And then you can disconnect your battery cable and put an ammeter in series with a battery cable if you're doing parasitic current draw. But if you want to then have the tool graph, because sometimes these parasitic phantom draws, we're going to do another class on that. We think we did one here a few weeks ago. I'm going to do some more with hands-on and case studies in the future because that seems to be a popular topic and it eats a lot of technicians' lunches. Battery drains, phantom battery drains that come and go. But like the Fluke Connect with the Bluetooth that streams to your phone so you can see it better on a bigger screen. The little screen on the power probe that plugs into the DLC for the parasitic draw testing will also stream to your iPhone. And you can record it that way. So you can do a screen recording if you know how to do that on your iPhone, and boom, you can watch trends and so forth over the course of minutes or hours, however long your battery holds up on your phone. All right, so let's go ahead and get started. Now, some of the specs, this is why I wanted to review a few of these slides. There's the VC. We're hooked up. Go ahead. Got a question? Oh, we got lots of feedback. Okay, Ryan's saying, yeah, maybe it's. Yeah, let me mute your mic, Paulo.
Yeah,
something's going on with that probably because it's the phone or something.
I want to see. This is quite. I missed the other one.
Okay, all right.
I don't want to miss this one.
All right.
Sorry.
How are we now, Ryan? How's the feedback
on the speaker? You can't hear me.
We good?
You can't hear me now because
okay. Ryan says much better. Wonderful. All right. Let's just keep rolling here. So this chart on the right.
You connect my sound at the beginning. Please disconnect.
Just down on mute everybody there. There we go. You guys can go ahead and hit the chat box. And then I can open you up for questions or whatever later if I need to. All right, so this chart on the right of the screen I'm sharing, is that the screen I'm sharing, by the way? I want to make sure it is. Yep, that's the screen I'm sharing. All right, so it gives you a specification, like W to U, ignition off. It's an ohm meter, so you want a dead circuit to work on. 136.4 to 150.8. Why the variation? Temperature. Temperature causes resistance to vary. You check the resistance of a light bulb with an ohm meter, it's one number, and then you look at the current draw and you do the Ohm's law and you go, well, that's changed. That resistance has really changed. And that's just the nature of electronics. Anytime you have colder or hotter, resistance will change. So that's kind of the cool thing about it's expensive. It's like 800 or 900 bucks. I got it from AES Wave, but this MT03A, this Pico version of a milliometer I'll be demonstrating, it actually has a temperature compensator. So it's a little probe that goes into the end of the Pico box. Looks like a small Pico scope, but it's not really a scope. But it does hook to your laptop, so it's PC based, and it will compensate for that temperature. So you put the probe down in the three-phase fuel pump, or the probe into the electric stator, electric motor generator, whatever, and it gets the reading because it maybe just came out of the vehicle or it's still in the vehicle and it's hot. Maybe it's a hybrid electric vehicle, or even the electric vehicles. They get really hot in a lot of areas, and that's why we have a very complicated cooling system and heating system to heat the battery pack up in wintertime. So those are specs, and they're out there in the service manuals. I'm starting to see them more and more. For a while, it was like, well, you're lucky if you see it in a Toyota manual and not necessarily a Mitchell All Data, but I'm seeing it everywhere now. So that's a good thing that they're keeping up to date. Now, the other thing for testing, which we won't do for brevity, is the resolvers. These are things you can look at with scan tool PIDs, look at, but to adjust, to change the resolver setting, that's basically a fancy term for a position sensor for a three-phase drive motor. You won't see those in a lot of other things like the fuel pump we're going to test. But in a drive motor, the computer wants to know exactly where that motor is. So there's a couple different designs. And if you've got the factory tool, I don't know what Autel and Snap-on, how they're doing so far with doing resets, but I know the factory tools can all have a function. If it does get messed up and out of place, you have to replace something like the resolver itself or the electric motor. There is a reset procedure that the factory scan tool can do. Otherwise, don't mess with it because it is difficult to change. All right, so we're not done. All right, so I'm just going to go back to that last slide, and I'm going to stop the share and turn on the camera for some live stuff. All right, so get the camera rolling here. Perfect. That's the one I want. And I got to figure out how to share that. I think I'm sharing it now. All right. Yeah, let's see. I'd like to see it full screen myself so I can keep an eye on what I'm doing. See if I can scrunch some stuff down to figure this out. Okay. Well, so far I made things worse. Okay. So now I'm going to stop the video. Well, wait a minute. Blur background. Let's try screen share. Well, crap. How do I make my camera full screen so I can see it? Okay. Oh, I see what I'm doing wrong here. Okay. All right. Share screen. There we go. Share that. So now, well, I had it. Bear with me, guys. I'm going to, okay, move that over there to that PowerPoint. See if I can make that big. Dock to top. That's probably not what I wanted to do. Video. That should be me. I don't even see a thumbnail of that either. There's a way to hide the video panel. I don't want to hide it. I don't want to. There's the USB. We're going to be mostly on that. Optimize for video sharing. That should do it. If I can just get it bigger. Okay. Well, I don't want that stuff. Trying to find the camera. Okay, I'm going to open up. We got 5 people on board here. Cool. Attendees. Hello, David, Matt. I'm going to, Paulos, you were on first. I'm going to unmute you. And please try to tell me if how much of the camera screen you can see, or you can hit the chat box if you're still muted. I just authorize you to unmute. Um, okay. I just killed the video. Okay. Turn it back on. No, you can see my hand there. Okay, David, I just allowed you to talk. I'm going to ask you to unmute there. Matt, same thing, allow to talk. Oh, David, I see your microphone is active, and I don't know if you're saying anything or not. I can see the VU meter. I'm just trying to get some feedback from you guys to let me know how much of the camera where my hand is waving, can you see everything in that camera? I need to know that before we go on to the actual hands-on testing.
I can see everything in the camera there.
Okay. Is it full screen on your phone or your laptop or whatever?
I see most of it, the pump and the testing equipment.
Yeah. Okay. All right.
But you have 2 screens. You have the one from your computer, the screen on the computer, and the one you're recording. Maybe
Okay.
what maybe what you need to do is just remove the one for the computer, not the one you're recording, and that should be okay.
Yes. And figure out how to do that.
Maybe so. Maybe if you go back to sharing and stop sharing
Yep.
and re-sharing again, only that one.
Hey, see, I
There
see
you
your
go.
family there. See your boy.
Yeah.
Good,
There you go. Now
good
it's
looking
full
kid. All
screen.
right.
That's
All right.
perfect.
See if you can figure that out. All right. Share is there. All right. So that should optimize for video sharing. I've got that turned on. Um, screens. Hold control to select two desktops. I don't want to do that. That's the only choice I've got is this guy right here. And it is so small on my end that I won't even be sure if I've got things covered here.
So, Dave, if you
Yeah.
go back the way you had it before, just
Mhm.
just one click back, it was perfect for us. We can
Really?
hear you. Yeah, we can
Okay, let
hear
me
you,
get
and
here.
we can see the whole recording of the live camera.
Yeah,
Okay.
I see
Yep.
one. Yeah, I see one photo
There
of
you
that.
go. There you go.
I have it right. Okay. All right. We'll leave it at that then. Okay. Now,
I don't know if that's your live camera.
yeah, that's you see my hand waving?
Yes, that's
Okay.
perfect.
All right. Well, that's probably maybe as big as I'm going to see it today without wasting any more time. Let's go to work here. Hands on. All right. So, first off, if you've got a problem and you're not sure, is it a phase resistance balance issue? Talking about phase resistance, I want you to think of it like on a Ford. I mean, every engine, ICE engine, you can do cylinder balance, where you can take the power, kill the spark, kill the fuel injector, whatever, and watch the tachometer. The scan tools can do it these days, but I think it's called power contribution. Somebody remind me on Fords, they've had this for years. And it gives you like a waveform of how much each cylinder was contributing. I believe it looks for crankshaft variations while it's running. Kind of like we do relative compression with the scope, looking for crankshaft speed, variations to indicate compressions occurring. They indicate that the engine is turning rhythmically, with good balance. Each cylinder is contributing to the movement of the crankshaft. I think it's called cylinder balance or power contribution balance, whatever. Very similar with three-phase motors. So let's just say you had a difference in resistance between U and V and V and W on those two different phases. This is what you can do with the milliohm meter. A regular ohm meter is not sensitive enough. It'll tell you, like 0.2 ohms, 0.21 ohms, and can you really trust that? So the milliohm meters really are like a microscope looking at a mosquito's legs or whatever. I mean, it is in detail, and it can help determine why a motor's not working properly or working at all. And we can also, if it's a higher voltage three-phase motor, like a drive motor for an EV or hybrid or an electric compressor. We can check the three phases on some of the electric compressors. Some are fed two DC cables, a positive and negative, right off the battery pack, and then there's a CAN bus that tells that compressor to do what it does, and it's a built-in three-phase inverter on the compressor. That's virtually every air conditioning compressor on every electric vehicle or hybrid or plug-in hybrid since about 2010 or 2015, somewhere in that time frame. But Toyota, for the first 15 years of their Prius, I think, something like that, 10 years, whatever, how long they've ever made them, they went to the Generation 3. Generation 2 used three-phase power going to the compressor itself. There was a miniature inverter board on the main inverter board that was, underneath that big cover on top of the earlier Priuses. So I have a version of one of those compressors to not today, and we'll check the resistance phase balance with a couple different milliohm meters, the VC and the Pico. But on the three-phase fuel pump, since they do make, in fact, Joe's Auto Electric makes this three-phase fuel pump driver module, it eliminates one more thing on the vehicle that could be causing a no start. So if you have a vehicle that's, low power, no start, is this an issue with the pump? Is this an issue with fuel? Is it an issue with the pump driver, the three-phase motor driver on the pump? Which I think I mentioned in the last session, part one on a Sienna, which all the Siennas since 21 have been hybrid, that fuel pump control module that drives that three-phase fuel pump in the tank in the back of the vehicle, that module is in the upper left kick panel. That's a lot of wiring to go that far to a fuel tank in the back of a Toyota Sienna hybrid minivan. So that if the wiring is an issue, or you're not sure it's the pump control module's a problem, substitute the pump control module with this little thing I'm going to show you next. All right, so I've already got a power supply hooked to it. If you can see right here where my fingers are, let me get the little small chair over here to place to dump some stuff. All right, let's get the three-phase milliometers out of the way for now. All right. And the one I've got already got plugged into the laptop. All right. So they're out of the way. So there's less clutter here. All right. All right. Now, so here we have power and ground into the pump driver module. This substitutes the driver module, this ECU, on the vehicle. Okay. This would work on a Chevy, a Toyota, you name it, anything using a three-phase fuel pump. And other three-phase motors that actually you can get to the three-phase connections. Now, it's not always the case. Like some blower motors, it is integral. The three-phase inverter is integral to the blower motor. In fact, the compressors, another example, where you have two big orange cables going into the compressor, a DC high voltage positive, DC high voltage negative, and then the compressor has its own integrated three-phase inverter that gets communications, power, ground, and CAN bus signal, and it does its thing. It makes a certain amount of three-phase power, and it varies the compressor speed. You wouldn't want to tear one of those apart because it's probably like taking your watch apart. You get it back together, it probably ain't going to work. So you wouldn't be able to use three-phase milliometer testing, phase balance testing on a motor like that. But here we have yeah, three phases. In fact, I've got three male terminals. Anytime you don't have high current and high voltage, low voltage stuff, sensors especially, how many millinewton meters is that? Heck, I don't know, but you got to have a good draggy feely, and I certainly have that with these terminals. So I got male Bell A terminals, and in my little MacGyver thing I did here over the weekend, I actually took some of these terminals right there, and I soldered them onto a banana plug female jack, and now I can actually hook into the connection. And I want a good connection, and I also want to make sure these are colored. Now, the colors obviously don't match here. I don't know if you can see that, okay? So the green and the blue, I don't have a green and a blue wire here. I've got yellow, red, and brown. But I did take the markings, and whether it's 1, 2, and 3 like Chevy does in their service manuals, or at Toyota, very good, they have a U, V, and W, which is traditional for any three-phase motor. I don't care if it's running a huge compressor or conveyor belt in a factory, or if it's just a little low voltage dude like this. Toyota uses those acronyms U, V, and W. They don't mean anything. They don't stand for anything. They're not short for a word. That's just arbitrary, like 1, 2, 3, A, B, C. In this case, U, V, and W, some of the last letters in the alphabet. So on this motor driver, the substitute, here I have it marked U, V, and W. All right. So U being blue, I'm going to keep blue dedicated to, and I already marked that with some label tape here. U is going to go to U. There we go. Oh, that's the shield. There we go. So I got a good connection there. And green is V, Victor. So that's going to go there. And yellow is W, as in whiskey. Okay. Now I hit the power button on the side of this thing. And again, you always hear this on these TV shows. Don't try this at home, okay? If you were going to run this fuel pump more than just say like half a second, you're going to run it. I want to run the fuel pump. First off, if it came out of the vehicle, you're going to get a bath when the fuel pump runs because this hose right here is going to be spraying fuel. It's still in the pump. So if you're going to run it for 30 seconds or whatever to keep it from overheating, you're not sure if it's bad or not. You're like Murphy's Law. Well, it wasn't bad before, but then I ran it without fuel. I ran it dry. I overheated it, just like running an engine without oil. So you would want to put this down into a basin of, you could use lamp oil, you could use gasoline, but I don't recommend it. You got, it's a fire hazard. Be squirting around the shop, maybe a spark, stray spark somewhere, and now you got yourself a fire in your shop. So I use lamp oil. It's less, the flash point is higher and it's less explosive. It will burn, but it's got a lubricated quality like gasoline. And of course, you'd want to flush it out and then before you put it back in the vehicle if it turns out to be a good pump. But for this case today, for brevity, we'll just go ahead and run it dry for a second or so you can hear it. So it's got a switch on the side. There it is right there. A little knob. I'm going to turn it on. I don't know if you can hear that with my microphone in the background. And at that point, you can hook your lab scope to it and see the pattern very similar to what we saw on that PowerPoint slide. We saw it last month. We saw it again, the review is today. And you could check to see what the waveform looked like. Is it, and you could even hook up a pressure gauge if you've got some kind of a test fluid rolling through this thing. But it's a way to eliminate one thing on the vehicle, and that is the module itself that this is replicating, okay? And tell you, hey, this pump can run in theory. So what's wrong with the wiring or what's wrong with the module in the vehicle that this is replicating, okay? Substituting. All right, let's go ahead and turn this off. Now let's get the ohmmeter, the milliohmmeter out after it. And what we'll do there is, remember those little test leads that I was using? Not leads, but terminals. So this thing is done for now. I'll put that back on the shelf behind me. Now let's get that little simple, inexpensive VC brand. And I mentioned this last month, I think. Now I'm going to turn it to the first available setting, which is, actually I'm going to turn it to the lowest setting. So I just turned this to 2 ohms. This is like any old-fashioned meter. It's digital, but the old-fashioned meters that were not auto-ranging, this is not auto-ranging when you do milliohmmeters. And the leads, instead of this being one lead and then an alligator clip, we have 2 leads. So each jaw of the alligator clip must touch. This is important. I'm going to repeat this again. Each jaw, each side of the alligator clip must touch the conductor, whether it be the wire, if you can sneak it in the back of that connector, or I like to do this, as long as you have the correct size terminal, you don't create a new problem. So I'm going to take that male blade, go into the V, another one into the W, and another one into, let me get this a little bit more on target and a little bit further down. There you go. That should help. Then another one into the U. All right. So now all 3 phases have male terminals, and these special alligator clips, they got a name. They're called Kelvin clips. That was a guy like Kirchhoff or Ohm. Kelvin was one of those early, Renaissance electronics inventors. And the Kelvin clips is the reason you can see these 2 leads per alligator clip. So both jaws must touch. And what it is, it's kind of like a push-pull. That's how they can get a milliohmmeter to be a milliohmmeter. Otherwise, it's just a fairly inaccurate ohmmeter that's good for higher resistances. This is stuff that's going to be very low resistance, but it needs to be really close. So as I hook this into that terminal, touching both jaws to the terminal I've used for testing, you'll see the meter show a number. Now I've on 2 ohms. Let's go ahead and back down until, just like we used to in the old days with regular non-auto ranging ohm meters, back down until we see a number. And I'm seeing 143.0, 143, 144, yep, 144 milliohms. And remember that chart we were looking at in the PowerPoint? That's what we're looking at. But that's just one combination of the 3 phases. That's Victor to whiskey, V to W. Let's go V to U. Doing the same thing. What do we have here? Make sure we're getting good connections here. We're doing something wrong here. Either that or I have broke this. There we go. If I can hold it still. 145, 146. Now let's go whiskey W to U. So all the combinations, there we go again. A little bit of fluctuation, get a good bite, and we're seeing like 142. So 142 to 144, you saw the specs that we had up there published from the Toyota service manual, for example, and that's what you're looking for. So this is a fine art of doing the phase balance. Normally, the failure would be a short or an open, but, you know, an engine, you could say normally would either be a misfire or a no start, but can you have a little bit of a rough engine because of unequal power contribution from some, I don't know, carbon, volumetric efficiency issue, whatever. So details and little nuances like that do matter, all right? Now, let's go ahead and do the same thing, but with the other meter. So let's demonstrate the Fluke 3-phase motor tester, which hooks to the laptop. So I'll have that little challenge to share the screen. I missed my brand and communications gal, Sarah. Those of you who are customers of ours watching us now, you're people of faith, please keep her in your prayers. She's way too young to be out on disability. I mean, not just like a broken ankle or something. That she's got some health issues, and he's kind of like a daughter to me. Very positive person, kind of person you want in your brand and communications team, you know, promoting PR and stuff with the company. And she was very, very helpful moderating these meetings and saying, Dave, they can't see your hands or whatever. All right. So I'm going to do the same thing here with these Kelvin clips for this 3-phase pump, but this is a little different. This Pico milliohm and motor tester, I'm going to get this turned around so you can see the label on it. It comes with a temperature compensator, this thing right here. So, I mean, if you wanted to, if you had, let's say, some fuel lines hooked up to a test reservoir with some, you know, gasoline, or better yet, some safety solvent for testing, you could actually put that down in it or just next to the pump itself, because, you know, it is a temperature sensitive thing. Like we said, temperature affects resistance. But all 3 of these Kelvin clips are into a phase, and now I'm going to hook up, I can find my USB cable, because just like any picoscope, it's USB connection. It'll be on my laptop. So I will then, next thing I'm going to do, hopefully this all works. This is like, this is always dangerous doing hands-on live, whether it be in a classroom with techs watching or on a camera. It's like doing circus animals and stuff. You never know how they're going to behave. All right. And get this turned around, David. There, perfect. Okay. So now I am into the software, theoretically. Let me open up the program, Pico. Here we go. And let me share a different screen now. And so you should be able to see screen 2. Nope. There we go. Let's do that. So do you see a screen what looks like a Y wound stator? Let's go ahead and hit the base bar and see if it starts working. I may have to close it. No, it stopped. Okay, let's see if we can start it again. Share. There we go. So I am sharing. And I've stopped the test. Lost connection. So I'm going to have to reboot the Pico. All right, I got to find it first on the desktop. And it's on the other desktop. Of course, I'm using 2 screens. Screen sharing is stopped as the window is closed. That's okay. All right, we'll reopen it here. So scopes and tools, scan tools, Pico milliohm and motor testing. There we go. And I will then shove this over to the other screen there. So now I will see if I can get my zoom controls back up. Flying solo here. What a handful. All right. Go to screen share. There we go. Share. And I want to share on 2. So you should now be seeing what I would see if I was a tech or a trainer in this case. So I have an electric motor tester. I can hit that, or a milliohm meter. So the electric motor tester, let's try that. Now it is connecting to the USB on the laptop and the tool. And it reminds us, hey, you're checking electric 3-phase motors. If they're high voltage, be careful, right? Explosions, fire, electric shock. It's like your mother's nagging you to be careful, okay? No joke in this about safety. Keep it safe. Make sure you know EV and hybrid safety and all that. And, gasoline spraying around if we're doing tests like we're doing right now with a fuel pump. All right. So now we'll hit continue. Test setup. Here we go. Why is it not cooperating? Okay. Oh, I got to accept. I got to click accept. I've read the warning. Okay, now test is in progress. Test not started, actually. Press the space bar. There we go. So there's the picture of a 3-phase Y-wound stator winding. It's checking between U and V. And you'll see the action going on with the animation. Now it's going to switch over to V and W. It gives the number. 143.82. Hey, didn't we see about 143 or 144 or 141 when we used the little VC, the little expensive tester? Worked the same way. This is just going to be a little self, and it gives us a bar graph. So you can see trends. This is where we could, wiggle wires and things like that. Maybe heat the motor up, cool it down, whatever. There's the temperature compensation for it as well. So it's going to take that into account when it does these measurements and it does this testing. And this is as simple as that. All right. So what we don't necessarily need to do is a leak test for checking insulation leakage. We don't need the mega ohmmeter because typically when you've got low voltage running a 3-phase motor, like a fuel pump, you're not really worried about, a chafed orange cable, like in a hybrid high voltage situation where you got leakage and the computer is looking for leakage, kind of like a GFI in your house. It sees a little imbalance, boom, trips the breaker and keeps you safe, in case the drill or the lathe or your wife's mix master or your microwave, whatever in the kitchen has an issue, no one's going to get hurt. So this is kind of like that, only a high tech version for leakage. We don't have that issue with low voltage, brushless DC motors like the fuel pump we just tested for phase balance. And it was, look how close these bar graphs are, and the numbers tell us the same thing, and then what we've compensated for with resistance. So if we didn't use that resistance test, a little probe, this is the number we would see without it, and this is the number using a compensation. So that is a big advantage feature with the Pico, which costs several times what the little VC costs. So I would recommend, if you're going to start out, getting used to your two new lady friends. Millie, that's what we are using here. This guy on the left and the guy on the right. I had that camera showing. And Meg, just to start out simple until you get your sea legs. If you want to specialize more in high voltage electric motors and so forth, then you can graduate up to the Pico MT03A, because like I said, they're like $800 or $900. And AES Wave will be glad to sell you either one. All right, out in Fresno, California. Good people. Okay, now let's stop the share of that, and we're going to pull the high voltage stuff in here now. And that's going to be a table swap, so bear with me. Let's see, how do I do the stop share? Okay. All right. Now we should be sharing the camera. All right. Now I'm going to move. I'm going to keep the milliometer, the Pico version, and get the fuel pump off camera. So everything else can kind of stay around, and I'm going to move my tool cart with some big heavy parts. You know what? Before we do that, let's go ahead and do, and I'll show you a real problem. On another three-phase motor, this would be a motor generator of a 48-volt design. Now, if you work on Volvo, you notice that, marketing-wise, Volvo says, all of our vehicles are electrified. Like, what does that mean? They're all hybrids? They're all electric? Well, it's either a full electric, a plug-in electric, or at the very least a full hybrid, or in this case, a low voltage, or called mid voltage, the blue cable stuff. So just like a Ram e-torque, or e-assist, I should say, or e-torque, what they say on the hood. The thing that looks like an alternator is a three-phase motor generator. On the Hemi, it looks like an alternator. On the Pentastar 3.6, it's kind of behind the water pump. It looks kind of weird. This would be like for a Volvo, and you can probably see, if I've got that camera video, yep, make sure, yep, I've got the right camera. I'm just not seeing the feedback of the camera. All right, where'd it go? Okay. Perfect. Okay, now I see it. Now you also see my right screen of a big old Delco Remy alternator. Hey, how appropriate. Only that is, you know what? That's got 4 outputs, 4 big terminals. That's interesting. So that's for the heavy duty stuff. And I just had a class from a very knowledgeable Delco Remy engineer at their service school in Anderson, Indiana. They still have a presence in Anderson, Indiana, with an engineering lab and warranty return analysis. And we had a heavy duty truck alternator starter class. So those are ran a couple times a year, and I think they're open to any customer that was working on the Class 8 trucks and bigger. That's what all this stuff is for. But it almost looks like a 3-phase output there, and maybe this big DC for 12 volts. I'm not sure. I'm an old auto electric guy, but I did most of the R&Rs, and my older brother did the rebuilding, the bench rebuilding on the big stuff. I did a lot of the small stuff, but it's kind of appropriate that that's on my screen share. But back to the camera right here, where my hand is, all right? So this looks like a regular alternator, like a CS130 off of a Chevy or something. But if you pick it up, Oh my gosh, it's way heavier than a normal alternator because it's a three-phase motor generator. I had one on a Malibu in 2013. It was huge. It was water cooled, everything. This would be like a proto that the engineers gave me. And it's been dropped, so you can see that it has a resolver. That's what this little brush and this oblong looking thing right here is. That's part of the position sensor or resolver for this three-phase U, V, and W electric motor generator. So it's belt driven. It can start the engine with the belt, and it can also then charge the vehicle's battery, 12-volt battery, but it has to change the three-phase down to DC. That's what the inverter does. So it does two jobs. Inverters can make three-phase AC, or they can rectify three-phase AC back to DC, and that's what alternators have done forever. They called alternators because they make alternating current. And the diode bridge inside the alternators did that inverter work, that rectification work. AC three-phase back into nice clean DC. Now, in this case, there would be an external AC inverter rectification unit on that Volvo. I actually got videos of one here recently. I don't have it with me today, but we'd have a 3-hour class. But they will do stop start like any vehicle does with 12 volts these days, only much better, and it will give you a boost in power, kind of like a little electric turbo. As this unit, the same thing is done by the e-torque or torque e-assist on the Ram pickups and so forth. But we'll also drop the 42 volts down to 14 to clean power and charge the 12-volt battery and also run the electrical system on the vehicle. But the same thing I did with the VC. Let's do that here. Make the measurement resistance tests. All right, so that should be in camera now. The meter. Let's see if we can get it more in the camera here. And I will turn it from off to, I think this is pretty low resistance. And I will just pick, eeny, meeny, miny, mo here. U and V or whatever. And we're seeing a number. So get that little bit more in the camera. Here we go. And that number is, it's 0.00. Let's get some higher resolution. Keep turning that knob. Here we go, a little bit more. Now we're showing 17.4. Yep, a little more definition there. 17.46. Now let's change to the other combination. So you would do this 3 times. And now we have 17.45, 45, 46, pretty dang close. And let's do the outer ones here. So the U and the W. UVW, and we have same thing. And we could do that also with the Pico fancier version, but we won't get too bogged down with that today, all right? But several more middle voltage, I'll call it mid voltage, the blue cable things. In this case, I'm going to be moving this motor generator from that would fit like a Volvo or Audi, actually. And here, this is electric power steering. This is a proto unit that the engineers were going to throw out, and they gave it to me. I'm going to go to these terminals. So those are the 3-phase terminals coming from some inverter somewhere that's changing DC into 3-phase 42 volts. I'm going to do the same test. Oop, it fell off. That I just did on the motor generator. This is electric power steering motor, mid voltage, brushless, and we see a number. Well, not yet. Let's go down. Now we are at 44.3. I like that. Okay, 44.3. Let's try a different combination. Here we go. I got an open. That's weird. Let's try this combination. I keep getting this open. What's up? Oh, not getting a good bite. Let's see if we can go to the outer perimeter of this thing. Nope. This copper looks pretty clean. There we go. 43.3. Go to the outers. 43.3. Let's go to this combination right here. I'm going to wiggle some wires in the back. See the wires wiggling and moving? I'm going to turn this around so you can see a close-up. So this is something we do anyways whenever we're using a voltmeter to do a voltage drop or using an ohm meter to check for resistance. So there's my 3 phases coming in. And this is where those terminals go into the motor itself. I don't know if we can get close enough to see this or not. I mean, I use my flashlight. Okay. Now, I cut some insulation back because, again, I don't care about this. It's a proto, and it was just getting thrown out of a lab. You might not want to do that, damage it in case of a warranty issue or whatever. But you can see if I pull that insulation back, it's nice and clean, except the red phase right here. I don't know if you can see that. Let me get a pocket screwdriver to kind of help pull some of that back. That is as green as a penny left out in the rain. So my hands are in the way. There we go. So the corrosion just sitting in my shop for however many years, for whatever reasons, attacked that cable. And so when I kind of wiggled down here with my fingers while using the milliohmmeter phase balance test, it was a definite problem detected. In fact, what we could do is go back to using the Pico to see if it's got an advantage of catching that. So now I want to measure all 3 of these with the Pico because I've got a UV and a W. Kelvin lead. Might call it like a 3-channel, okay? Let's go ahead and share another screen here, okay? Now, Pico, there we go. Now I'm going to share that screen. Okay. There we go. So you should be seeing a familiar looking thing, and it's testing each phase one at a time. Automated process. And I do see some variations, and probably if I wiggled while I did it again, I'd see even greater variations. So we're seeing, anything from 42.6 to 44.16. And if I wiggled, this is why I plug Scott Brown in his P10 video. He's reading a teleprompter at first, talking all about this great tool, as PTM does in their videos and their magazines, talking about tools. They're all wonderful, right? But then he got to actually demonstrating it, and you could tell the trainer and the practical shop owner in him came right out, and he did a great job. So I encourage you to just use Google and find Scott Brown and the MT03A Pico milliohm and motor tester. But he was able to find a phantom CAN bus resistance issue with this tool. So I'm optimistic. I'm rewriting our CAN bus class and updating that. I want to try to find a real problem on a real car, the CAN bus, and see if this little tester can shine for that particular cause. All right. So let's go ahead and go to the high voltage stuff. So that's medium voltage. So 42 volt stuff, and then the 12 volt or low voltage BLDC fuel pump. We've got those out of the way. Now, so that I don't break my back, I'm going to move the test equipment because we're going to also be introducing the high voltage leak tester. So with the low voltage stuff, and now the little table comes out of the way. Bear with me while I get everything untangled. And we'll bring that big old motor generator stator over here and that electric compressor. So here comes the tool cart. This is all inside my house, by the way. My wife is the wife of the year, putting up with all this crap that's literally 5 feet from her kitchen. Ugh. I say, honey, there's no PCBs I'm aware of to cause cancer. All right. That I'm aware of. All right. Get this a little higher so you can see what's going on. All right. Now let's share that. All right. So I've got the table shared, and for whatever reason, uh, the background is also being shared here. Perfect. Okay, I see them both now. I apologize for that. I gotta, hopefully by the time I do the second one of these, I'll have that little bug worked out. All right. So there's my big stator, okay? And if I pull this over a little bit more, get it in camera, I'm going to go ahead
Showing
and,
both screens now, and one
what's
screen
that?
is quite small.
You okay? What? I couldn't hear you. All right. So this is your electric compressor. There's the windings inside of it. I've taken it apart. There's the big heavy permanent magnet. I'll demonstrate the permanent magnet part. There you go. That's a magnet, mate. Okay. So there is that. That is and that is hard to get out. Big old pair of pliers or vice grips recommended. And that goes down in there. And this is the connector for it all. I'm going to pull this connector out. There'd be 3-phase orange insulated cables. Smaller versions of this right here that would lead from the inverter, sub-inverter on a Generation 2 Toyota hybrid system, like a Prius. And there's my U, V, and W right here where my finger's pointing. So I'm going to go ahead and check these two with the VC, get the VC back on camera, and get it for the... All right, so we're seeing 0.61, or no, 0.621 is what we're seeing. I'll just lay that on that stator. I don't know if you guys can see the meter. Yep, you can see the meter. So here we go. And if I go to another phase combination, 0.62, all right, let's go to another one. 0.61 and a half. Go to another combination. 0.61. Could do the same thing with the fancy Pico version. But what we're doing is we're looking to see, kind of like with cylinder contribution, power contribution, is this electric motor, at least resistance-wise, balanced? And obviously, if you saw 0.0, that's a short between two phases. A burnt spot could do that, or some kind of insulation breakdown. Commonly, using the wrong oils. You're like, hey, use universal oil, whatever, and you get corrosion and stuff build up. You have problems with these AC compressors. So don't be a junior chemist. And, I'll use the oil I like, and I'll use the coolant I like, in vehicles that are electrified. Use what the factory recommends, okay? So find that information out. Now, last but not least, and we'll finish up here, we'll use the mega ohmmeter as well, because high voltage stuff, we got to look for leakage. So let's do one more phase balance with the little VC. And I'll go between a U and a V on this big stator. Get that to behave itself. There we go. And put that on top of the stator. Run out of places to put stuff. I wonder if it likes that magnet. Oh boy. All right. So you can see the meter, and I'm out of the range, so I adjust my range to get a reading. There we go. 3.43 milliohms. Change combinations, U to V, V to W, and so forth. And you have 3.43. So very close. Again, we could better use the Pico. Does a more thorough job, does it all at once, pretty automated. Let's do Meg now. So I've already introduced you to Millie. Let's finish up with our friend Meg, mega ohm meter. And we would use that on devices that are high voltage to see if it's leaking. We got some kind of leakage of orange cables or the actual windings itself. So I will turn on the mega ohm meter, and we have usually a different place to put the leads. So I've got a lead that has the Fluke 1587 has a little remote activated to do the test here in the lead itself. There's a button right where my thumb is touching, okay? So I'll need one more lead. You always need two leads. It's going to be the test lead the high voltage is going to come out of, but it's got to come back to the meter. It's got a little inverter built into it, little step-up transformer. It's using, I think, 4 AA batteries, but from that, 6 volts or whatever that it adds up to, we're looking at anything between 50 and 1,000 volts. We can increment up with this Fluke and actually put up to 1,000 volts of very low current, but it will shock you. You will actually, if you get a hold of the leads while you're in test mode, it will definitely give you a jolt. So if you got a heart issue, a pacemaker, don't play with it. It's like don't get around spark plug wires when their engine's running either, right? Same thing here. Now, I'm going to put a alligator. Yeah, I didn't bring an alligator clip. I'll just go ahead and touch it here. So I'm going to go between like a chassis. This is the body. See if it's leaking between here and the winding. And I will turn the meter on to insulation test, and it will turn my backlight on, and it defaulted to 1,000. How to change the range. And what should the range be? Always look and see what the motor gets. In this case, this drive motor would never get more than, let's say, 360 volts if it came out of an EV or plug-in hybrid, or maybe 250 volts if it came out of a hybrid. So what's the next step up? As we jump through these ranges, we go 50, 100, 250, 500, and 1,000. Well, since in boost converter mode, where we actually can give 650 volts through some magic step-up transformers in the main inverter and give three-phase higher voltage than the battery itself, we can, like on a plug-in hybrid, we can get 650, or even in a generation 2 or 3 Prius, we can get 650 volts up to that under hard acceleration. So what's the next step up from 650? 1,000. So it's a safer step up, go to the next step higher. And I will put that on here, and I'm going to hit the button now. Watch the meter. Is the backlight on? The backlight is on. Okay. I hit the remote button. I can also hit the button right there, and it says 2.1, 2.2 gigaohms per speed. It's putting out 1,053 volts. I go over to the next one. I do the same thing. Now, obviously, if you see some arcing or something like that, it's a clue that you are definitely, and I've seen this before, you are definitely got a bad stator winding in a 3-phase motor, or in a cable for that matter, an orange cable. It's used for both. And so here we got a very good high resistance, no leakage. And there's specs on this. So if you don't see 2.2 gig, if you see some number, watch, I'm going to create a short circuit. I'm just going to go to the chassis like the other lead is going to now. I'll hit the button, it'll say 0.0. Or just make a little bit of a spot in there to the actual, get something besides 2.2. It's either going to be 2.2, which is basically an open, which is what it should be, or I touch the other ground, the lead to the other ground, and I have a dead short, demonstrating my meter's working 0.0. So the specs for insulation resistance are published more and more, like I talked about with phase balance resistance with milliohmmeter. Mega ohmmeters are designed to check for leakage. And by the way, I've actually used them on fouled spark plugs before. So without having just like an old vehicle that still had some plug wires and a common coil, I was able to identify without taking plugs out. This only works on a hot engine. I've actually tried fouled spark plugs on the bench in the lab, and they're all cooled down. You know, the type you talk oil fouled, you know, like got a valve guide issue or valve stem seal and a dead miss, and you know which cylinder it is, but maybe the miss is so sporadic, it looks like all the cylinders are misfiring. Well, that's a case of I need to know which one it is. I don't want to take all the plugs out. I want to save time, especially if it's one of those engines where I got to pull the top of the intake off to even to get to the other spark plugs and get to three, but I can't get to the other three. If you got access to the secondary wires or secondary connections or even the top of the coil, you can use the mega ohm meter for another function besides hybrid voltage, high voltage in electrification. You can use it. You will see, and I've actually captured a vehicle that had horribly fouled number 6 spark plug, oil fouled, and it had a different resistance, a little lower resistance between chassis ground and that particular spark plug wire at the other end of the spark plug wire than all the other cylinders. And I told the tech, I said, pull that plug out. I'll bet you'll find it. That's the culprit. He did put another spark plug in, and now we didn't have any P0300s and all kinds of other codes that can set when a severe misfire is occurring and doesn't give you much clues of which cylinder it is. That's just one more tool in your arsenal of using mega ohmmeters and milliohmmeters to do your job. All right. So I will go ahead and close with that. Change my little screen there. On behalf of Delphi, thanks for watching. I can't get these things under 80 minutes, so I went 60 plus 20 bonus minutes. Hopefully you didn't get in trouble with the boss and you can get back to work. Thank you for your time, and we will see you on another one. And actually, we're going to be doing one every week. So next week is going to be Rick Escalumbre talking about, and he's an excellent monitor. He was known as Mr. Monitor on IATN for years, but he is an excellent trainer for anything that has to do with emission monitors. And he's going to talk about EVAP before the smoke machines came out. So basically testing EVAP codes, EVAP monitors with and without smoke. It'll be great. You'll want to watch that. That's going to be also, again, noon Eastern, noon, the same thing repeated, noon Pacific time. Rick's actually from the West Coast. So make sure you tune in to my buddy Rick Escalumbre. He'll be putting it on Facebook. He is a Facebook guy until we get our brand and communication team back up, hitting on all 8 cylinders. We're going to be, the instructor is going to be, promoting these Tech Tip Thursdays. I appreciate all of you for logging in and being here with me today. God bless you. And if you've got any questions, I think I've got that PowerPoint up and my contact information, or you can hit me through Facebook if we're friends on Facebook, which we probably are. Let me see if I can share that screen again. Okay. And first off, I got to get the screen up. There we go. Yep, there's my personal contact info. So I will, now, come on. Share. I don't want to share that. You've already seen enough of me. Stop share. Okay, share. Perfect, right there. So there is my contact info. DAHobbs at fania.com. And there's my cell phone. Text me. Leave me a voicemail. If I don't recognize your phone number, I never answer the call because you knows who it is these days. But 765-480-4976. Love to hear from you. So hopefully we're just going through a phase with the awkwardness with Zoom. And we'll get a moderator back on board helping us out. Until then, thanks you for your patience and for your interest. God bless you. Enjoy the rest of your day.
Thank you very much. All the best here from Ukraine.
Thank you.